This video provides easy-to-follow instructions for you to create this drain plate using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we'll read the engineering drawing for this drain plate. The drawings provide all of the information we need to model this part using Onshape. Let's start by identifying the views. This drawing contains 2 standard views. First, the isometric view shows a pictorial. This helps us visualize the part in 3 dimensions. Next, the orthographic drawings show 2 principal views. In the lower left corner, the front view. Aligned above the front view, the top view. When planning the parametric model, we need to identify the basic shapes and features. The top view shows the shape as a circular plate. The front view shows it has a uniform thickness. The top view shows a rectangular pattern of small holes centered on the circular plate. The hidden lines in the front view shows the holes extending through the plate. The top view shows the part is symmetrical left to right and front to back. Next, we will look at the dimensions and notes. First, the measurement units are in millimeters. The material thickness is 5 millimeters. The outside diameter of the plate is 150 millimeters. The hole size is 5 millimeters. This is the typical size of all of the holes. The distance between the holes in the pattern is 10 millimeters measured center to center both horizontally and vertically. The hole pattern is centered on the plate. The material is copper. The mass is measured in kilograms. Before we model the part in Onshape, we have to establish our design intent. For this project, we intend our model to be flexible to possible design changes and update predictively without errors. To start, we need to identify any features that might be changed or revised during the design process. First, the thickness of the plate might change. Also, the diameter might be changed larger or smaller. The diameter of the holes might need to be adjusted larger. The hole spacing might need to change. Next, we need to identify the features that should remain unchanged when the part is revised. The part should maintain its circular shape. The hole pattern will remain centered and symmetrical to the plate. The choice of constraints and the order they are applied will determine if the model will behave predictively when changed. So, I want to be able to change the diameter of the plate and the spacing of the hole pattern, and be able to edit the number and placement of the holes in the pattern, as well as changing the diameter of the holes and have the part will update without errors. Before we model the part in Onshape, let's preview the steps in the modeling process. First, from the drawings we need to identify the profile or closed region that we'll use for the first sketch. We will use the circular profile from the drawing for our base sketch, and we will place it on the top sketch plane. The origin will be placed at the center of the circle. So we have placed sketch 1 on the top sketch plane, centered on the origin. Next, we extrude sketch 1 to create the base feature, the plate. Sketch 2 will define the hole size and locations for 1/4 of the pattern. Extrude 2 will remove material to create the holes. Mirror 1 will duplicate extrude 2 to form half the pattern. Mirror 2 will add the remaining half of the pattern. This results in the completed part. I've started a new Onshape document and named it Drain Plate. In the workspace units, the length should be set to millimeters and the mass to kilograms. I'll start a new sketch in this part studio. Click on the top sketch plane. Use N on the keyboard to view normal and P to turn off the visibility of the sketch planes. From the toolbar, choose Center Point Circle. Click coincident to the origin to start the circle. Enter 150 millimeters for the diameter. This looks correct, so click on the green check to accept the sketch. We can now use Sketch 1 to extrude the base feature. From the Feature toolbar, click on the Extrude tool. This will be new. Click on Sketch 1. The direction should be above the sketch plane. Set the depth to 5 mm. Click the green check to accept and create the base part. Notice, Extrude 1 is now listed on the feature list. Next, we will create 1/4 of the whole pattern. Click on the Sketch button on the toolbar and, for the sketch plane, choose the top face of the plate. Use N on the keyboard to view normal. We will start with the hole at the center. From the toolbar, choose Center Point Circle. Click coincident to the origin for the center of the circle. Enter 5 mm as the diameter. Now we can use the circle to create the pattern. On the toolbar, click on the Pattern feature and choose Linear Pattern. Click on the small circle to be patterned. Double-click on the vertical item count and enter 6. Set the horizontal value the same. For the distance between centers, enter 10 mm. This looks correct. Click the left mouse button to end the pattern tool. Use the green check to accept the sketch. Next, we will create the holes forming 1/4 of the pattern. From the Feature toolbar, click on Extrude. Click on Remove. For the sketch, click on Sketch 2 in the feature list. And set the N type to Through All. Examining the pattern, the hole closest to the edge is not needed. Click the mouse on this hole to remove it from the selection. That looks right. Click on the green check to accept the feature. Next, we can use a feature mirror to duplicate the whole pattern, left to right, and then top to bottom. From the Feature toolbar, click on the Mirror feature. From the drop-down menu, choose Feature Mirror. For the feature to mirror, choose Extrude 2 in the feature list. For the mirror plane, we will use the default right plane. Use P on the keyboard to turn on the visibility of the planes. Click on the right plane to choose it. That looks right. Click on the green check to accept. We can now mirror this set of hole to the bottom. Again, click on the Mirror tool in the Feature toolbar. Again, choose Feature Mirror. For the features to mirror, click on both Extrude 2 and Mirror 1 in the feature list. For the mirror plane, click on the front plane. That looks correct. Click the green check to accept. The drain plate is complete. The material is copper, so let's change the color to something more appropriate. That's better. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass unit should be set to kilograms and the material set to copper. If the size and shape of your model was completed accurately, the mass should be 0.687 kilograms. Let's look at this process step by step. First, open the document that contains the model of the drain plate. Next, check the workspace units and make sure that mass was set to kilograms. Next, set the material to copper. Go to the part in the parts list. Right-click and choose Assign Material. In this case, we're searching for copper. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 0.687 kilograms. If this was your result, then your part is accurate and matches the specifications. If not, we can troubleshoot to locate the sketch or feature that has an error. First, locate the rollback bar in the feature list. Move the rollback bar up to just below Extrude 1. The mass now reads 0.79 kilograms. An error here would be in Sketch 1 or Extrude 1. Now move the rollback bar down to below Extrude 2. This adds the first set of holes for the pattern. The mass is now 0.759 kilograms. An error here would be in Sketch 2. Move the bar to the end. Again, the mass should be 0.687 kilograms. In this segment, we'll make some changes to the design and check if our design intent has been applied correctly. We will start by reading the revision drawings to identify the features that will be changed. First, the thickness has changed to 7 millimeters. The diameter of the plate has been increased to 200 millimeters. The diameter of the holes has been increased to 7 millimeters. The distance between holes in the pattern has been increased to 15 millimeters. The total number of holes in the pattern has been reduced by removing additional holes at the corners of the pattern. The revised mass should now be 1.703 kilograms. Now we will make the revisions to the drain plate. We can create the revised part in its own Part Studio by duplicating our original part. Right-click on the Drain Plate Part Studio tab and from the pop-up menu choose Duplicate. Right-click on the tab of the copy and click on Rename. Call it Revision 1. Click on the tab for Revision 1 to open it for editing. We will start by updating the thickness. Double-click on Extrude 1. Edit the depth to 7 millimeters. Next, change the diameter of the plate. Double-click on Sketch 1. Edit the diameter to 200 millimeters. Now we need to make changes to the elements in the pattern. Double-click on Sketch 2. Here we can change the hole size to 7 millimeters. Change the spacing to 15 millimeters. That looks right. Last, we need to remove a couple of holes on the edge. Double-click on Extrude 2. Click to select and remove the extra holes on the edge. With the revisions done, let's check the mass. The mass is 1.703 kilograms. The revision is accurate and has no errors in the feature list.